If you're looking to build your first RAG system, you're definitely in the right place. In this video, I am going to show you step by step how to go from data and building a retrieval system and then using an LLM for the output. And as well, if you just want to practice, I'm sure that it will be challenging for you. We're going to use open source entirely, and this will definitely be good practice for you. In order to do this tutorial, I would ask that you download the materials. You'll find a link in the description and as well the first comment of this video. And what you will find there, so you'll find some requirements for this. You'll also find a prompt engineering ebook. And the most important one is that you'll find a starter file with some data and, just a little bit of code. Therefore, this is some data about Berlin. And this is what we are going to build our RAG system on. What we want, we kind of want a tour guide that answers things about, Germany and Berlin that come from this data and this data alone. And for instance, if you were to ask, what about, France, then there would be no answer because that's not part of the data. The best way that I would describe a RAG is imagine that you're cheating in an exam. And the thing is that if you use an LLM, that's basically, cheating using whatever, using something that some random person in the class is writing in the exam. But a RAG, you can pick your data. This means that you can find the best student. You use their data and then you copy from them. That's how I would put it. Let's get started. We need to do some setup here and we need an API key. This is absolutely free, but we need an API key from Hugging Faiss. Let me go there. I'm going to log out just to show to you. If you go to huggingfaiss.co, then you click on sign up, confirm that you are a human. Doesn't matter if you're lying, that's okay. Then you're like, okay, let's specify which ones are chair. So this is chair, 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 and this looks like a chair. That is it. Wait, what? This is also a chair. Okay, that's tricky. Okay, bags. This is a bag, this is a bag, 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 bag. I'm going to call this a bag as well. Okay, I'm failing at human apparently. Okay, the hats. 1, 2, 3, 4, 5. Here we go. Here you go, success. You include your email address, you include the password. You also eventually get asked for an avatar and so on. And then you just log in. It's absolutely free. I'm going to log in. Wait, I actually need to put my username, but let me put my face recognition. And here you go. So this is my username. Let me log in. And then here, what we are going to do is that we're going to get a key. So you go to your avatar, you go to access tokens. You're going to create a new token. You're going to call it whatever, but I call mine HF token. And then click on write. That's my usually pick. And then you create the token. Let me get it here. So you have this token that is here, which I'm going to delete in a bit because I have one already. And then you're going to copy. It's very important that you copy it now and you store it because you'll not be able to see it again after you close this modal. And then you copy it, you go to your starter file, and then you store it here as a secret on Google Colab. And these are API keys that are safe and they go from notebook to notebook. So this setup, in case that use Hugging Faiss again, you just need to do it once. Then you can just go with one notebook after the other. I'm going to activate my HF token. So I'm going to click here on done. In case that You want to delete it, you go here to the three dots and you click on delete. That is it. So I have here my HF token and I go to my starter file. And actually in the secrets, you have here some code to actually, retrieve the token, which mine is HF token Hugging Face key equals to this. And let me do Shift Enter. Then I'm going to import OS, and I'm going to set OS environment, and I'm going to set the Hugging Face Hub API token as the HF key. And this is how we are now connected to the Hugging Face. Now I need to install a bunch of libraries. So pip install Faiss CPU Langchain Hugging Face sentence transformers Langchain community, and then we add the queue for quietly, so we don't have like a lot of output here. And it's almost installed. I can start by import libraries from okay, let me take all of this and then see what we need. So from Langchain underscore Hugging Face, I import the Hugging Face embeddings. I do want, so from I do want the Faiss from langchain.vectorstores.Faiss. I import Faiss from Langchain. Okay, this is not used. And then from Langchain.doc store.document, I'm going to import document from, by the way, I also need to add here. So I'm going to add chat, Hugging Face, and then comma, Hugging Face endpoint. Here we go. Like, feel free to pause here and make sure that you have everything correct. This is case sensitive. And then we'll go from Langchain underscore core dot messages. We're going to import the human message and the system message. There you go. Here we have it. Let me do Shift Enter. Oh, and I'm missing one. So from IPython. This is just make sure that we are showing the outputs of the LLM in a nicer way. If I am to give a summary of what we're doing here, so we're going to prepare the documents in a very specific way. Then we're going to do some embeddings, and we're going to store it in a database called Faiss. Then we're going to use the human message, the system message, to format our inputs, which are then going to be used by the chat Hugging Face and the Hugging Face endpoint to then produce an output that we're then going to show with the display markdown. Easy, right? Let's get started. The first step is really the embeddings here. And here you go. So we start by kind of like preparing the way that we do it. So we do document page content equals text. And then we do for text. And I think I forgot to activate this, but this is called documents. And we're going to go through each of these elements in a list. So for each of these sentences, and we are going to store it in a way or in a format that's easily accessible with Langchain for text in documents. Here we go. So if we do this, this is the output. So for each, we have a document, no metadata, we have a page content, and that is it. So we store this under docs, and then we can continue. What we do now is that we create some embeddings. So let me add this. So wrap in a document, we add the capital D. So this is part 1. Then we are going to use the embedding model. We're going to use a specific one that I like to use. We're going to have this embedding model. And currently, so far, we're just specifying, so Hugging Face embeddings. And then inside, we specify the model name, which is the sentence transformers. I don't know if you recall, but we did install this library. And it's called all mini, capital M, LM, and then L6 V2. Again, feel free to stop here, make sure that you have everything correct. And then finally, we create a Faiss database. What do we include in the database? So we have this Faiss DB, and then we use Faiss from documents. We include the documents and the embedding model. Let me do Shift Enter. And I know that this is still running, but what is happening is that we're just getting the model currently to our script, and then we're going to apply the model to our documents to then store the data in the database. And this is actually setup, everything. So I know I called it embeddings, but this is setup. And this is now we get to the RAG part, which is the retrieval and augmented generation. And this is the retrieval part. So build the retrieval. And this is like super straightforward. Build the retrieval. The way that we are going to do it is that we're just going to get, so define a function. So for retrieval. And this is supposed to be very easy. So it's just define retrieve docs. And inside, we are going to do it based on a query. And we are going to specify how many. Like k equals to 5 is usually a good value. 10 is also a good value. And we save them here. So docs Faiss. We go to our Faiss database. We use the similarity search. And what is happening is that we are comparing the query and the embeddings of the query. And we are comparing it with the embeddings of all of our data and all of our documents. And the top 5 most similar documents to our query, these are the ones that are retrieved. Let's test this. So test the retrieval system. Retrieval system. Here we go. So query, what is the capital of Germany? And yeah, can use, let me get our docs Faiss. Here we go. And we get documents. Of course, we get 5 documents. And first one is actually like Berlin is the capital and largest city of Germany by both area and population. So just the first one. And then we have quite a bit of information as well. The most important thing is that we get the top 5. It doesn't mean that the top 5 are relevant or even that we are just getting the most relevant. It means that we're getting 5. And then the LLM needs to actually figure out how to do this. How? I'm going to show it to you. And this is it when it comes to the retrieval. Then we are going to build the generative system. We're going to use a model for this, which is the Faiss 3.5. So filter by name, Faiss, and 3.5 mini. And this is, it's a bit worse. So if you have it here, you don't see it properly in this table, but it's worse, slightly worse than the GPT-4o mini, somewhat equivalent to the Llama 8 billion. So if you see here, for the Faiss 3.5, we get an average of 55.2, definitely inferior to the 76 of the 4o mini, somewhat equivalent to this Gemma, also worse than the Gemini 1.5 Flash, and equivalent to this Mistral as well. Now, let's get started. As well, important is that this is a 3.5 and this is a 3.8 billion parameter, right? So it's a tiny one. So if you think that it gets us similar outcomes to the 12 billion from Mistral, the 9 billion from Gemma with like half of the parameters, I think we're getting a good bang for our buck in terms of memory and capacity. Let's get started. So we're going to load the Phi 3.5 model. So this is our LLM. We use this Hugging Face endpoint. We specify the repo ID. And so that you don't really make a mistake, you can come here to our Hugging Face. Let me see, where is it? Here we go. All the way. This is using transformers. I'm using Langchain. I think my implementation is much easier. But if you want, you can also just copy this. It's fine. It's going to result in the same, but I think this application is easier. So here we go. And then you also specify the task. There's two types of task. There's text summary, and there is text generation, which is what we're going to use because it's retrieval augmented generation. We're not doing summaries here. And just so that I complete this, we have the chat model. And here we have the chat Hugging Face. And then here we specify the LLM is the LLM. So Shift Enter. This is going to now get and retrieve the model here. And then we are going to define a function to ask the LLM. Here we go. So define ask. We are going to include first, just a query. Here we go. Then we also need to specify our messages here. Oopsie. Here we go, messages. And we have here the system message. You are a tour guide. And then we have the human message. So content is the query that we would specify. And then we have response equals chat model. This is an old version. For newer Langchain, you need to use .invoke. Then you include messages. And then you return display, or better yet, we return the response, and then let's build from there so that we also take this step by step. We're going to apply the function here. Apply the function. So we're going to define query response. What is the capital of Germany? And then we're going to print the response. You see here this content here. The way that we can avoid it is that we add response.content. Let's me do Control Enter. Here now it's better edited. And then just to make sure that we have a very nice output here, we add display mark down, then we close parentheses. Here we go. And this way, this is a nice, we get this none here, which is rubbish. But this is a nicer way to get an output. And this is the generation. And then the question here for us is, the RAG system. Here we go. So I'm going to get here the function for ask, because I'm going to, tweak it a bit. I'm going to call it ask2. And this ask2 will have a query and will have a context. What is the context? The context comes from the retrieval. You are a tour guide, and then for the content here, we will do with an F string answer the query based on the context, right? So this is what we should do. And this is like the most standard version. Let me do this, and I'm just going to add the triple double quotes so that we can kind of like play around with this. So this is our ask2. And then we can actually build our RAG. So we come here, and then we are going to define the function for RAG, define ask, RAG, and here we just include the query. Here we go. What happens is that we will have here, let me see if I'm missing something. So we'll have here our queries, we'll have our documents. And here we go. So we'll have our context, which comes from the retrieve docs query. And then we'll have our response, but here we can just use the return ask2. So we have the query, and then we have the context, which has as an input the query, and then the ask2 as the context and the query. And here, then we can play around. So test the ask RAG function. What is the capital of Germany? Print response. And here you go. Capital of Germany is Berlin. What is the capital of France? Let's see what we get out of it. So documents provide not explicitly state the capital of France. However, based on your role as a tour guide and general knowledge, the capital of France is Paris. Not ideal. We just want from our context. And the way that we do it is that we come here. You are a tour guide. Just answer queries based on context. Let me add an F string. If you don't have the information, just say you don't know. And these two sentences, answer based on the context. If you don't have the information, say you don't know, these are pivotal. And these are like a pro tip to making this RAG actually function. Here we go. I don't have the information in the provide documents to answer what the capital of France is. Now, I would appreciate it if it was not verbose. It does continue to indicate the capital of France is Paris, which is a bit unfortunate. Just the capital, just answer the question. The query is based on queries. If the information is not in the context, say you must say you don't know. Okay, let me try one last time. This is the part where you kind of need to, tweak and make sure that is here. Now we actually get the output. So these would be the pro tip, that you need to tweak the system message in order to have like a fully function RAG system that doesn't, answer what it shouldn't. Because that's really the purpose of RAG, to make sure that it answers on the data that you provide and not on anything else. Hope you enjoy this. You'll also find a link to a course that I have on RAG in the description, and I'll see you in the next video.